Hello, welcome once again to my channel, OJ Charles. Today we want to talk about integration. We want to give some little introductory examples to integration. Um, Integration is a technique used in finding a function when the derivative is given. It is used to reverse the derivative process or the differential process. So when a function is given and you know you found the differential calculus, you use differential calculus to determine the derivative, you can use integration to reverse back to where the function where it all started. That is the purpose of integration. And Uh, there are two forms of integral or types. It can be definite integral or integration, or an indefinite integration. It could be indefinite or definite. A definite integration is an integral which is to be calculated between two fixed limits, where there is a lower limit and an upper limit. Now that is a definite integral, a definite integral. But the indefinite integral, is just an antiderivative approach without limit. It is an antiderivative approach without any form of a fixed limit, without any form of fixed limit. So where the definite integral, you have what we call the upper limit and a lower limit. That is like placing a limit to how far you can go on the point. So these are just simple way of putting them for you to clearly understand, since we are just giving into small introductions about this. So what happened is that the indefinite integral is more like the definition of integration that we gave, while the definite integral goes further. It's like it has it goes further to reduce the function. It goes further in reducing the function. So there are rules as well, just like differentiation, just like the differential calculus. There are rules. If you have a constant, for instance, you have to integrate a constant. This is the integral sign. This is the integral sign. So if you have, let's say, k, a constant, it means this k is the derivative of a function. So if you are to integrate this function, what you are going to have is simple. The constant with an introduction of a variable, say x. Of course, this dx have already shown that the function is a function of x. So you introduce an x to it, which gives you a kx plus a new constant. You understand? So if, for instance, there is no constant, like maybe you're just giving this dx, it means that of course it means that this function is a derivative. Now, since there is no x, what happens is there will be an introduction of what? X and a constant. Because what happens is that in integration, since it is the reverse, of differentiation, in the integration, the power increases, but in differentiation, the power reduces. So in integration, the power increases. So where there is no, the power of the, that is the power of the variable increases. So where there is no variable, it means that when you integrate, the variable assumed raised to power 1. Of course, we don't put raised to power 1, you understand? So the variable becomes raised to power 1. So we have an introduced variable. You understand? So in event where you have, for instance, sorry, this is supposed to be, let's use an example now to explain it. Where you have something like this, 2dx, what you have is an introduction of x, that is 1 power of x, or x raised to power 1 with a constant. This is what you will get when you integrate. You understand? This is what you get when you integrate, because the powers of the variable increases by 1. The powers of the variable increases by 1. So we go further to a second rule. A second rule whereby if you have, for instance, x raised to power, the integral of x raised to power n dx, of course the general rule, this is more like the general rule, what happens is that this x will increase in power. X raised to power 1, n will increase in power. You add 1 to it, all over that same increase in the power becomes denominator for the function, which will in the end divide the coefficient of this variable that may come. Then you introduce your c. Now this is the general this is the general rule. So we can use a more comprehensive example. We can use a more comprehensive example. For instance, let's say this is example 2. You have a function. You have to integrate this. Of course, if you are given this and you're asked to integrate this function, without being told, the first thing you assume is that you are going to use a definite, this function is a definite integration. You don't have to go and use definite approach. Once it is given just like this, it is simply an indefinite integral or integration. So what if the question comes, if you are going to use a definite approach, it will be given differently, because there will be a limit, there will be a limit, there will be a number here, let's say 4, and there will be 2 here. So take note of that. That is how you differentiate the questions. You understand? So there will be a number in the upper, the upper limit, the upper limit, and the lower limit. So take note. But this case is not a definite integral. So take note. When you see it like this, what you do is use an indefinite approach, which is the general rule that we have just given. So what do you do from here is simple. Applying this, you have this x raised to power 3, you add 1 to it, all over this same increase in power, 3 plus 1 becomes the denominator, then bring your minus here, and you repeat the same thing for this, which is 6x. This time around 1 plus 1, because the x carries the power of 1 in the first place. Then 1 plus 1 comes here, and you add your constant, and you add your what? Your constant. Then it's going very simply. What you do next is x raised to power 4 all over 4 minus 6x raised to power 2 over 2 plus c. So what you end up having is 1 over 4 x raised to power 4 minus 2 here 1, 2 here 3, minus 3x raised to power 2 plus c. You've just successfully integrated the function. You just successfully integrate the function. You could have another example. Maybe let's say it could be a little bit more complex. That should be example 3. It should be a little bit more complex. That should be example 3. Let's see. Let's say you are to integrate this function. Let's say it's given differently, so that you just say, okay, given the function y prime equals to 3x plus x plus 5. If it is given like this, of course, remember, when you differentiate, if a function is given and you differentiate, it becomes y prime. So when you are given y prime like this, it means you have been given a function like this, raised to power 2 plus x plus 5. This is what you have been given. To what? To integrate. So you start using the same approach. It's still as simple as that. Plus 5 equal to, then what you do is 3x raised to power 2 plus 1 all over, bring down the increase in power, then plus x raised to power 1 plus 1 all over 1 plus 1. Of course, all over 1 plus 1. Then plus 5. You now introduce x following the rule here. Don't forget. So 5, of course, it's raised to power 1, so you don't need to put anything. And it's going to be all over 1 too, but we can just put it so that you will understand. But it's mathematically erroneous to be putting raised to power 1 here, so you can just put it just for you to understand later. Then you introduce your c. You understand? So at the end of the day, you have 3x raised to power 3 all over 3 plus x raised to power 2 all over 2 plus 5x plus c. Okay, sorry about that, 2. Okay, this is what you get. So from here, it is quite simple. 3 will take away 3. So what you have now is x raised to power 3 plus 1 over 2 x raised to power 2 plus 5x plus c. And we are done. It's as simple as that. It's as simple as that. So please feel free to drop a comment, make a suggestion that will make my my videos, my teachings more impactful. If you have any comment, whatever suggestion you have, please, I will welcome it. In the next video, I'll be giving examples of definite integral, how to calculate a definite integral in the next video. Thank you very much. Please like, subscribe, and share so that we have more audience. Thank you very much, and see you next time.